started now. Welcome everybody to Foundations of Programming Day 8. Today we're going to start Objects and Classes. Hope you guys had a good day. Yesterday we wrapped up the Python crash course. Before we start today's lesson, I want to make a quick disclaimer that if there's any time to not miss class, I would recommend not be the next following days, right? So today we finally start class and objects. Tomorrow we start we might even touch it up today. Object-oriented programming, but it all into kind of combines together. So this is probably the most important part of foundations of programming and why it was really built, right? To increase the success rate for our students for the initial gate that you guys are going to encounter through the program itself. I said it before and I'll say it again. The object-oriented programming assessment is probably the most difficult one. Because I think because it's probably the first one, right? Granted, the Django one I think was difficult for us too, but by then you kind of already have a good understanding of coding principles. You have a solid foundation in programming that by the time you get to React or Django, you can pick those up. But that initial gap between starting the code and then getting an understanding of coding itself, it's pretty large. And then to be thrown straight into the pit for object-oriented programming, it's tough. Not to say that you guys can't do it, but we're trying to make it so you guys don't struggle as much actually doing it. So if you guys miss any class, highly recommend, if you miss class and didn't catch up on the videos, do not miss these videos. Go back and actually see them, because this is where it can get a little bit difficult. I might lose some of you guys if you guys are not used to object-oriented programming. If you guys have questions, do stop me. Ask questions. Don't let me continue talking and move on if a topic just goes over your head or you just don't understand it. Also, we have Brandon here, so we can always just go into a breakout room and get some one-on-one tutoring here. So before I even start objects and classes, do you guys have any questions about Python up to this point? Anything that was covered from yesterday at all? All right. Notice that we only had 11 participants today, right? That's me and Brandon included. That's 9. We started off with like 16 of you guys. And now it's like at 9, unfortunately. It happens. Life happens. But for those of you guys that are sitting here in this class right now, good on you guys. I promise you it's going to pay off once you guys start. It happens every class. Once the immersive program starts, a handful of you guys will message me telling me like, "Oh my god, like you have like, I didn't understand how difficult this assessment was going to be or object-oriented programming." Like I'm really grateful that I went through the foundation of programming because I would be completely lost. So it happens all the time. So good on you guys for being here and making it through so far. We're close to being halfway through the program, so that's awesome. So I'm gonna go ahead and start off today's lesson. Share my screen. We're gonna go ahead and start off on lesson 8, right? Classes and objects. So what is a class? All right, so we talked about earlier what functions were and how functions are kind of like a recipe for an action, right? So instructions. A class can be something similar to it, but I like to think of classes more of a blueprint, right? So think of it as a factory for creating a new object, right? The way of organizing your code. Class objects can be used over and over again, so it's also a way of keeping your code dry, as in the don't repeat yourself method. And we see a little image here where we have a car, and the car is the representation of what a car class would be with some attributes, right? We know cars having, they all come in different types of colors. Each car that we have is some type of make and model, as well as different fuel types, right? These are just very basic attributes that most cars have, or every pretty much car has, right? These are the default settings of what a car is. And then we see them branch out into what we see as objects, right? Car objects. One object over here is yellow. It's a Ford Mustang, runs on gasoline. The second one is a red Toyota Prius, a hybrid. And then we have the blue Volkswagen Golf, and runs on diesel, right? All three of these come from the car class. And what they all share in similarity is the same attributes. Every single one of them has a color. They all have a make and model, and they have a fuel type, right? What classes allow us to do is pretty much create the blueprint for what a default version of something what it should be, and then it allows us to create different variations of that class, right? It organizes our code, and it keeps us from repeating ourselves, constantly remaking what a car should be, right? We create what a default class, what every single car should be, and then we can kind of branch off and make different variations of it, right? The class syntax. All right, the class keyword is used to define the class, right? If you recall the functions, how do we define a function? We use def, right? Def for defining a def function. For class, it's as simple as typing in class and then the name of the class, right? The name of the class should start with a capital letter, right? If it has multiple words, we type it in as camel case, right? So if it was, for example, uh, 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 I can't even think of an example. Uh, Animal types, right? If you had like animal types, it would just be, capital case animal, and then types will also be capital case, right? It will be in camel case. So you want to start off with capital letters. And then we have our constructor, which is your init method, right? The init method is automatically called by Python when creating an object class, right? The init method is what initiates your actual object. So we start the class by using class and the name of it, and then we pass it its very first, I guess you could call it a function or a method. The init method itself is a constructor. And this is where it gets the information of what the class should be, right? We define that method by using def, very similar to a function, and we use double underscores, right? So we have double underscore init for initialize, right? Init stands for initialize, and then we finish it off with double underscores right afterwards, right? And then with open and close parentheses. The parameters or arguments within these parentheses is what's going to define what our class is. The very first parameter it takes is self. Self is just representing the class itself. It's almost talking like in a third person. Think of it like that, right? Who am I? Right? I am self. Pet. The class pet itself, that's what self is. It's pretty much saying this is who I am. After self, it takes the different attributes of the class. Pet has two different attributes, one being species and one being name. The actual code block itself is where we define what the parameters are being passed in, what they are. Right? So we see self dot underscore species, and then we assign the species parameter that was passed within the init method, right? Same thing with name. We take the parameter that was given within the init method and assign it to the self dot underscore name attribute. So this right here, the code block, the self dot underscore variables are attributes, right? This is what defines what the class pet is. Make sense so far?
The self is like using this in JavaScript, right?
Correct. It's like using this. That's a perfect example, right? Self is like using this. It's referring to the class itself. It's calling upon itself to instantiate it. It's pretty much saying, hey, this class has an attribute species. This class has an attribute name. Well, what is the value of that attribute? Well, that value is coming from the parameters that's being passed within the init method, right? Similar to whenever you guys create a function, you guys create a function with different parameters, and then you have access to those parameters, and you can do stuff with it. Same concept when it comes to uh, the init method, right? How does a class know what different attributes it's supposed to have? Well, you define that within the init method, and then you assign them within the code block. The init method does not need to take parameters for every data member, right? It depends on whether it will always be initialized with the same value, right? So if you guys recall, in our functions, we were able to set default, right? Default parameters, and then we were able to override them if needed. The init method can do something very similar. So refers to the object itself as an I, or as Gary asked earlier, as this, right? It's calling upon itself. The code snippet you see here on the right side gives you two examples of a customizable robot and a non-customizable robot. Notice that both of these classes, they all start with an init method. One has parameters and one doesn't. The non-customizable robot, it doesn't have anything. All it has is self, right? And then within the actual code block, we have sensors, actuators, name, and state. It has attributes, but we define the attributes directly within the code block itself. It's not taking anything from the init method, right? The init method is completely empty. So that means whenever you instantiate or you call this class, it doesn't have to take anything within the parentheses. The moment we instantiate this class, it will already have sensors, actuators, name, and state assigned to it, right? These are predetermined by the blueprint, right? By the class itself, right? Sensors, it has a list of 3 different sensors: a gyrometer, a LiDAR, and a camera. The actuators has wheels, LEDs. The name is data, and the state is on, right? Immediately, the robot itself, it already starts off in a state where it's already on. The name of that robot is data, and it starts with different sensors and actuators. You're not able to pass in anything whenever within the actual init method to try to change it. These are the default settings. And then we have a customizable robot, where the init method, it does take different parameters. We have the sensors, actuators, and name actually being passed in with here, right? And then we assign whatever is given within the parentheses into the attributes, right? Sensors is assigned to self.sensors. Actuators is assigned to self.actuators. Name is assigned to self.name. Notice that the state starts off in off, and the operating system starts off as Linux. These are set as default, but we're able to customize the sensors and actuators as well as the name for this robot, right? Instantiating a class, right? Creating a pet object. So here we see the pet class again. They have the init method. It takes 2 attributes, or I guess 2 arguments, being species and name, and then they assign it within the code block. They assign it to its attributes. Then we create 2 different classes, right? Pet1 and Pet2. Notice for the class to be essentially, they call the class pet, right? And then they actually pass in within the parentheses what arguments it's going to take. Pet takes capybara. The capybara takes the place of species, and then Beatrice takes the place of name. Same thing for pet 2. The species is kangaroo, and the name is Joey, right? We then print pet underscore 1 dot name, pet underscore 2 dot name, and they print it out, and we see it prints out the Beatrice and Joey. You guys are more than welcome to kind of code it if you guys like. and we can kind of try that out so we can kind of mess around with this. So we'll say classes example.py, right? We'll create a class called, we're not even gonna do pet, we'll do dogs. And dogs is a good example because they come in different breeds. All right, so we can create our own class here. We'll call it class dog. And then we're going to define an init method. And you guys are welcome to code along, and I encourage it. As you guys recall, it's supposed to take a self. And we can just pass for now, right? It needs an init method so you can initialize, but it doesn't necessarily have to have anything with the init method, right? We can define a different method in here, right? So the init method will initialize the class itself, but we can do other methods to allow this dog to do stuff. We can define the ability for it to bark, right? And this will allow it to do different things. I don't recall it. Does it need to take self? I don't think it needs to take self. All right, this class should have.
I thought it did.
Ooh, let me lower my volume. That hurt my ears.
Sorry. I thought you did have to pass self with them.
Let's try it out. I haven't messed with this in a while. We'll do dog1 is equal to dog. We call the dog class. As you recall, the init method doesn't take any parameters, so we should be able to just do dog itself like that. Let's print out dog1. What does it give us? CD less than 8. Python classic example, right? There we go. So we run the classic example py that we just created, where in line 10 is printing out dog, and we see what it prints out. It says, it's some weird jargon, you probably won't understand it, but it says main.dog object at, and then it gives us like this code here. You don't have to understand what it's saying. It's pretty much just letting you know where this class is stored in memory. It's pretty much just hashed, but the dog was created, right? The dog does exist. Now let's do dog1 dot bark, and self. I think you're right. There we go. Let's clear it up so you guys don't get confused with all the extra code. We are printing out on line 10 dog. It prints out the object. It gives us some weird code, but know that this is pretty much telling us that it does exist. And then on line 11, we're calling our class, and we're using the bark method, right? The bark method is allowing our dog to actually bark, right? On line 7, we have print bark, and we see it's actually doing what it should be doing, right? This dog is able to bark. All right, well, let's go ahead and add some characteristics to this dog. We want to take in a name, and we're going to take in a breed. And as you guys recall of how we assign these attributes, we have to use self dot, and then the name itself, right? We want to create a name attribute, and we're going to assign it name. We want to create the breed attribute. We're going to assign it breed. Let's get rid of pass. Let's create a different method called give me attributes. Print self.name. Just so we can see this work. Name and breed. What are you talking about? It didn't method. Oh, my bad. So I'm getting an error here, right? It says a dog init missing 2 required position arguments. Well, why is that? Well, because we created this dog on line 14, and initially we had passed because the init method didn't take any attributes or any parameters. But now we changed what our name method is supposed to have. So we're getting an error because we couldn't create the dog because it's supposed to take in name and breed. So dog 1 is going to be called feudal life for my Hispanics out there. And it's going to take in Chihuahua. There we go. We can print that out. We see line 15 is still doing what it should be doing. It's printing out the instance of our dog. The dog exists. Line 16 is using the .bark method, right, which allows our dog to bark. And then we have a method that allows us to grab the attributes and display it to us, and prints out feudal lives and Chihuahua. Right. Pretty straightforward. We can create other dogs as well. We can do dog 2 is equal to dog. This one will be, I have a dog called Oliver, and he is a golden retriever. Let's grab dog 2, and we're going to see our attributes. Still getting the same thing, right? So dog 1, when he gives us the attributes, we get feudal lives and Chihuahua. Dog 2, when it gives us its attributes, it gives us Oliver and golden retriever. Right? Cool. So recap, we created our little blueprint, right? The class for dog. And the blueprint for this dog is taking in a name and a breed, and we assign it to our attributes right here on self.name and self.breed. This dog has the ability to bark, and also has the ability to give us its name and its breed. Right? When thinking about class and objects, think of it in the manner that, like, you are the creator, right? You're trying to create different things. This is how I like to imagine it, right? I have my own little world. I am the creator of this world, and I'm trying to populate my world. And I don't want to create every single animal, every species, every single thing into my world from scratch. So how can I make it easier for myself? I can create a blueprint, right? That blueprint is my class. This blueprint allows me to keep myself from repeating myself constantly every time I want to create something. And I save myself time by creating that blueprint of the animal that I'm trying to create. In this situation, I'm trying to create a dog and populate the world full of dogs. So I create this blueprint that takes specific attributes, and it allows me to recreate dogs in this manner, where I don't have to constantly make a new dog from scratch. All I have to do is call the dog class and pass it in 2 different attributes, being Oliver and golden retriever, and I can recreate that dog a lot faster than trying to recreate them from scratch. Right? Everyone still with me? Awesome.
Hey,
Brandon?
yeah, could we just real quick, could we go over the dunder string or dunder repr method? Because I genuinely believe it makes working with these class objects a lot simpler.
Yeah. So right now, whenever we print out our object, right, we instantiate our object dog1. It exists, and whenever we print out dog1, it's giving us some weird code here, right? It's like main underscore dog, right? Object at some weird location, and that's not very readable to us as human. So there is a method where you can kind of override what we receive whenever we print out our object, and that's via the method of the dunder method, right? So the init method is what we call a dunder method, dunder for double underscore, right? That's why they're called dunder methods, because they use the double underscore before and after to identify them. and you're able to override what it prints out by using the double underscore method of string. Right? You're able to do define double underscore str double underscore, and then you can return something, right? What this does, come again?
Yeah, you could just do you could just return self, name, and breed.
Correct, right? So you go to the the dunder method string, and we will return. And you can format a string if you like here, or you can just go ahead and do something like this, where you return self.name, right? So whenever we run this, let's get rid of all this so we don't get extra code. Clear. Right, we print out dog on line 21, and notice that it no longer gives us some weird code with a hash. It's giving us self.name, right? We essentially override the response that the console gives us when we try to print out the class, right? And it gives us what we added into the dunder method string. So when we print out dog1, it gives us self.name for that dog, which is, as we know, fetal lies. We can go ahead and print out dog2, and it'll give us Oliver, right? So it overrides the response from printing out that object to whatever we define it for it. For here, it was self.name. It comes into use whenever you're trying to create multiple objects and see if these objects exist and the objects were created. It can get very confusing when you're trying to print objects out and you're like, okay, I'm getting an object back, but I don't know which object is which. By overriding the response of your print method for your objects, it allows you to get a better representation of what object you have created, right? And it can be anything. Right here, we just return self.name. It can return a formatted string, right?
This is a dog with the name self.name.
Yeah, right here we're just returning self.name, right? We're returning the attribute. We can return a formatted string as well and say I am, and then open and close curly brackets and put in self.name. And notice that it returns with I am fetal lies, I am Oliver, right? We can format it to or whatever string you want to do. If this was a class that holds multiple different attributes in here where there's like name, age, it could print all that out in the formatted manner. If it was like a class for your users, whenever you're creating the users for your application, if you want to see if your user class is working and it's creating the users, you can respond with like the email and the name of that person to get a better representation of what classes are being created. So this dunder method, it's very helpful to visualize what your classes are doing.
Can I ask a question about that, Roger?
Of course.
So that string method is, you have to put what you want, almost like console.log sort of thing. You have to put in there what you want it to do, show up instead of that weird object location thing.
Correct.
Okay. Okay, thanks.
Where am I grabbing this dunder method? These can be found as well, right? So Python dunder methods, you can look up Python dunder methods, and these are methods that come with class and objects. There's different versions of it. We see here, different ones. We have new, init, delete. We just covered init, right, to get called by the new method. So there's all types of dunder methods that you guys can use. The ones that I use the most, honestly, the only one I use the most is honestly the string method. Defines behavior for when string is called on an instance of your class, right? So you can define what it gives you. But there's other dunder methods you can use. Kind of just do your own research and figure out which ones can be useful for you, if any of these can help you or not, right? But that's where that's coming from. I'm not just pulling anything out of thin air.
Yeah, the dunder string and dunder repr, which are you'll have to look into repr a little bit, but they are impressively useful for debugging purposes. You're not always going to use them, but it's very helpful to know that it exists. So try not to forget that it exists.
Exactly what Brandon said. But yeah, that is a nice little method to kind of use when you guys first start off to see if your objects are being instantiated as they
Roger,
should. Yes.
can you return more than one attribute
For which one?
for that string dunder?
I've never tried multiple attributes.
What do
But
you mean return multiple?
Like self.name and self.breed?
oh yes,
Yeah.
I am self.name. And you can say and my breed is self.breed, right? You can return multiple ones, right? I am utilized, my breed is Chihuahua. So you can add that to your formatted string.
Okay, thank you.
No problem. Anybody else? Awesome. So that was a quick down and dirty of how to instantiate a class using the init method and giving it different methods as well of doing stuff. So what are these objects, right? So the class objects that are made are just containers for storing data and functionality. These objects have properties like name or species, but they can also have methods that do things. And we saw that here earlier when we made the dog bark. We saw it whenever we wanted to receive the attributes. Remember, ultimately, this is a tool for organizing our code, right? Here, you see the pet method as well. Again, they have the species and name, and then we have to set to say something. It returns a string of what you want it to say, and whatnot. Hey everyone, my name is Beatrice, and I'm a proud capybara. All right. You probably noticed the underscore before our attributes, right? So this is what we essentially refer to as a private data member, right? So some languages have a keyword private. If you guys are familiar with Java, Java is pretty much strictly an object-oriented programming language, right? The entirety of Java is pretty much all classes and objects, and they have the ability to privatize these classes, right? Who can call them and what they can call and whatnot, right? And the attributes that you can call. You can directly put private whenever you construct your class. Python, unfortunately, does not have that feature, right? But the developers kind of built in their version of a way of privatizing data members, right? And the way they do that is by using the underscore. Last class, someone was talking about using 2 underscores to privatize the data member. You can do that too. One or the other. Some people use 1 underscore, some people use 2. They will both work. But there's no built-in method to privatize the data members right now in Python. It's kind of just the way how they do things, trying to make different attributes private in their own shape, way, or form. And they do that by adding the underscore method, right? Because typically, if we look at our dog class, if we try to access a data member from here, right? This dog has name and breed. We could do something like print dog1.breed. And we see here that it prints out Chihuahua, right? It prints out the breed of dog1, which essentially it's Chihuahua. So you can access data members of different classes by using the dot method. Well, by adding that underscore within the attribute inside the init method, when we try to print it out, we get an error, right? It keeps people from directly accessing data members or attributes of that class directly. So we add that underscore to try to keep people just accessing it directly. It doesn't make it actually private, right? If I came here and I just added an underscore, they will be able to did you mean breed self dot oh, it's actually not letting me. But you see how like it doesn't let you access it. Some people use 2 underscores, but they can't necessarily access it directly. Well, there's a way to grabbing this, and that's by using a getter method, right? So it's not necessarily private, but we use these underscores to keep people from just accessing that data attribute straight off the bat, just like we did earlier when we didn't have the underscore. Right here, doesn't have an underscore. I call it dog.breed. It gives us Chihuahua. We add the underscore. They can't access it. Right. So it's kind of like a what's the way I'm looking the word I'm looking for? It's kind of like a backwards way of doing it, where it's not built into Python itself, but we do it as just a standard procedure for trying to propertize data members. And that's what they did when you see here on the code snippet self dot underscore account ID, self dot underscore balance. That keeps people from come again.
I like to think of it as like honor among thieves, right? Like where putting that underscore next to your property is going to let other developers know, like, hey, if you access this directly, you could seriously break something, so don't do it.
Yeah, that's a perfect example of doing it, right? It lets you know, like, don't mess with this attribute. This needs to stay private and keep you from directly manipulating it, right? And the way we were supposed to access it is in this manner, right? So if it was just like this, I believe we should be able to do. We could do dog underscore dot breed is equal to what's it? We say pickle. Print dog underscore 1 dot breed. And notice that on line 21, we called the dog one, we referenced its attribute breed, and we changed it, right? We changed the attribute of that class, and then we print it out again, and it gives us pitbull. Right, so people are able to manually change attributes straight from the attribute itself just by calling it and changing it. Well, by adding that underscore, you prevent people from manipulating attributes that they shouldn't be manipulating, right? If a data member should be manipulated, we use what we call a setter method, which essentially is a method just like bark or give me attributes, but we'll do something like change breed, right? And then we essentially will do self.breed is equal to whatever we want to change it to, right? New breed, right? We privatized it, so they shouldn't be able to directly manipulate it. But in the event that they do need to manipulate it, they should have to use the method that we declared. So they would do dog underscore 1 dot change breed, and here is where they can change it. Let's go with husky. Dog 1. Let's print that breed. Give breed. We'll say print for now. Oh.
Hey Roger, I have a question for it's a little ahead from right now, whenever you're finished.
Yeah, give me a second. Let me just go ahead and do this real quick. Python classes has no breed. Where is, give me this, line 8. Okay, because I changed it. Okay. Get breed, it's not working. We need, let's return third, so underscore breed. Chihuahua change breed husky. Oh, that's why. Okay, there we go. See if we can just do print here. Print self underscore breed. I'm sorry, I know this might be a little confusing real quick, and I'll explain to you guys what I'm doing. Okay. All right, so when we privatize a data member, like we did here on breed, they're not able to directly manipulate it, right? So I saw earlier, we were able to just do dog underscore one dot breed, and we could print it out and see what the breed is. When you privatize it, it keeps them from directly manipulating this attribute. So if they have to be able to reference it or see what it is, we create what we call getter and setter methods, right? The setter method allows you to change the breed. So instead of them directly accessing that data member, you create a method that allows it to change it for them. And we did that here by creating this method called change breed that takes in the new breed that's supposed to be changed. And then we reassign self.underscore breed, right? We use that here on line 22 where we changed the breed to husky. We didn't directly access the attribute. We provided them a method to change it, right? So essentially you prioritize everything else, and if there's something that needs to be changed or they should have the ability to change it, you provide them a method to do it. But that way it keeps them from directly accessing that data member, right? And they should be able to also see what it is. You can provide a getter method, like we see here, give breed, that prints out the breed for them. Once again, it prevents them from accessing directly the attributes that we declared, but they're still able to use them if they needed to, right? We changed it here using the change breed method, and then we grabbed it as well by using the give breed method. We changed it, and then we make sure to see if it changed by using give breed method. We printed out, and it gave us husky. So earlier, when we didn't have that underscore prior to the name, we're able to just call the dot breed attribute directly and just manipulate it. And we don't want that, right? We want to keep people from directly messing with the attributes of our objects. But we can also provide the methods for them to do it if needed to. That way you can privatize everything and then just give them access to what they need. There's no purpose of letting them to access everything within our class. Only specific things that should be able to change, right? Does this make some kind of sense to you guys? I see man nods. Good stuff, right? That's why we have the underscore methods, right? We privatize these data members. We don't want people to just come here and start messing with our code. But if something needs to be changed, we can provide that method for them. It keeps them from just changing stuff and breaking it by accident, right? So some languages have a keyword private. Python does not have that. That means certain data members or methods can't be accessed from outside the class. Python does not have such a keyword, so the convention is to start that data member of method with an underscore. We just discussed that. We see here on the bank account, right? there's certain things that people shouldn't have direct access to. They shouldn't just be able to change someone's account ID whenever they decide to. So they privatize that account ID. They shouldn't just be able to change the balance either, unless there's a specific reason why they have to. And only certain people should be able to do that. But we should be able to see what it is. And we see that here by the get account ID. It returns the account ID, but it doesn't allow them to access it and change it directly. We can show it to them. Hey, this is what the account ID, but you don't have access to change this, right? And that's when that underscore really comes into play of why it's important. Cool. Right, accessing private data members, right? So notice in our bank account class that we have specific methods that set values of certain data members. We have the account ID, we have the balance. We also have methods that can get the value of certain data members as well. We have the get count ID, and now we see some additional ones, which is setting the account ID and also grabbing that account balance, right? So the account ID strictly only returns what the ID is, but it does not allow them to change it. In the event they have to change it, we create a method for them to allow them to access it. And we see that here by define set underscore account underscore ID. They take in a new ID as an argument, and then the data member is set within this method. They don't have access to directly manipulate that data member or every other data member. It's only strictly that account ID, right? Then we get down to the balance one as well. This method only allows them to view what the balance is. They do not have access to changing it. Right, this idea is important because it gives us more control over who can access the data members and who can't. Printing objects of a user-defined class. All right, so printing this kind of object returns a class it belongs to and its address in memory. Not very helpful. We did jump the gun a little bit about this, but just a quick recap, right? Whenever we instantiate that dog class, we printed out the dog. And we got that weird funkiness where it gave us like main, the class, and the fact that it's an object, and it gave us some weird hash code, and we didn't know where that was, right? That's the location of that object within memory, but that didn't really help us, right? We talked about the ability to override that and change it to something that we can read and understand by using the dunder method str for string and change that ourselves. All right, later in the course, we will cover how to redefine the behavior of the print function for these type of objects. We already covered that. Congratulations. Right. So, quick little meme, objects everywhere. So wait, it's all objects, right? Everything in Python, it always has been. Most of your stuff is going to be objects. Once you guys get into Django, you'll see that you'll pretty much create objects upon objects. And it helps you kind of format your code so it's easily readable and reusable, and just neatly formatted. All right, here's gonna be our first practice assignment, which is gonna be taxicab.py. Go ahead and open that up. If you go to lesson 8, go to taxicab. You should have something very empty. The taxicab.py should be empty. And your job is going to be to write a class name taxicab that has 3 private data members, right? So recap, private data members, that means they have a underscore prior to their name. One that holds the current X coordinate, one that holds the current Y coordinate, and one that holds the current odometer reading. All right, so thinking about what a cab is, right? Remember, like your cars have an odometer of where or how many miles they've traveled, right? The X coordinate and the Y coordinate is going to tell you where that taxi cab is at. And every time the X or Y coordinate moves, that means the cab is moving, whether it move forward, right, back, left, or right. That X and Y is going to change. And if that changes, that means your odometer needs to change as well because your cab has moved. So therefore, you've actually added some knowledge to your stuff, right? So we see a nice little code snippet here. We have our object, which is going to be called cab. And then instantiate a text cab, right? When I say instantiate, what I'm trying to say is you pretty much create a cab, right? Up to this point, you create the class. But once you actually create an object itself, we call it instantiating it, right? We bring it into existence, right? By bringing it to existence, we're actually calling the class itself and passing into parameters and making that object, right? They instantiate a taxi cab here, and it takes in 2 arguments. It took in 5 and -8, right? The 5 is probably the x-axis, and the y-axis is the -8. It creates a taxi cab object at coordinates 5 and -8, right? These attributes are set into the x coordinate and the y coordinate data members that the taxi cab should have. Next, you need to create different methods to allow the ability to change the position of that x and y coordinate. We see here they use the cab.moveX and moveY class method. Notice that it takes in an argument, and it's in a number here. We have one for x, it's 3. The one for y is -4, and then x again is -1. So that means this cab is moving. We're manipulating the data member that belongs to this cab, right? Every time we move it, there should be a method that changes that data member, right? So we saw that earlier. We created a data member that updated the breed of the dog, right? So change breed. Imagine that here on the taxi cab, your method is going to be called moveX or moveY. And what that should do is it should take in a parameter and it should update the data member that belongs to that class, right? And then finally, we see here on line 15, they're printing out cab.get odometer. Odometer should return to you the current odometer reading of your cab. All right. Obviously, every time that move X or move Y happens and you update that data member, you probably gonna have to update your odometer as well. So make sure that in your move_X or move_Y method, you're also grabbing the odometer and updating it with the new reading, right? And we see here at this point, the cab has traveled 3 + 4 + 1, so 8 units, and is now at coordinates 7 -12, right? So the class should have an init method that takes 2 parameters and uses them to initialize the coordinates and also initialize the odometer to 0. We talked about presetting defaults, right? Remember, we talked about the customizable robot and the non-customizable robot. The non-customizable, I'm sorry, English is my second language. The non-customizable robot didn't take any parameters. It automatically preset it, the sensors that it had, the name of the robot within its data members. So you should probably do that with your odometer as well. Every new cab should probably start at 0 because it has not moved. It's a brand new cab. So whenever you instantiate your taxi cab, you should have self._odometer is equal to 0, right? The only parameters that should be taken should be the x and y coordinate, and then you set that into your data members. You should have a method called moveX that takes a parameter that tells how far the taxi cab should shift left or right, and then have a method called moveY that takes a parameter that tells how far the taxi cab has shifted up or down, right? Simple enough. All right, let's give that a good 10 minutes. And then as soon as you guys are done, go into a 10-minute break. So you guys have from now to 6:33 to work on the assignment and then go into your 10-minute break. And then we will cover this once you guys return. Hopefully you guys were able to get the main gist of the assignment. If you did not, do not fret. We will cover it together in a talk through code along. Right. So I have here the assignment as well as the readme to the side of it. And we're gonna start out very slow to ensure that everyone is on the exact same page, right? So we are essentially creating the class of a taxi cab, right? So as mentioned before, to create a class, we're gonna start with the class method, and then we're going to type in taxi cab and camel case. And the very first method that we have to add is going to be our init method. And the init method is what's going to allow us to initialize and bring our taxi cab to life, right? So when we talk about methods, all right, they're essentially just functions, right? So you can use the words interchangeably, but when I say method, essentially at its core function, it's a function, right? This function is creating something. right? So the first method itself is going to be our init method, and this is what's going to bring life to our cap, right? Actually give it some value of what our cap is. As mentioned before, because it is within a class, we have to use self, right? Self is talking like in third person, right? Think about it like as if James is the cap itself, like, oh, I am James. James has wheels. James has odometer, right? Like that's what self is saying, right? So self is just talking almost like if it's a third person referring to itself. And then reading through the README, it says that our class should have an init method that takes 2 parameters, right? It takes 2 parameters. And that's the keyword here. Takes, whether it having more parameters, right? So when it takes 2 parameters, that means we have to deliberate passing something into our taxicab class to be instantiated. It doesn't mean that it only has 2 data members. It could have other ones, but it's supposed to take at least 2. Right, and the data members it's supposed to take is going to be move X and move Y. I'm sorry, correction. It's not move X, move Y. It's going to be just X and Y, right? The X and Y is going to represent where our taxicab is going to start off at, right? It doesn't just appear out of nowhere in some random location. We need to actually put this cab somewhere, and our X and Y is going to tell us where we're placing this cab at. Now, we know what we're taking, but we need to assign it to something, right? It doesn't know what X and Y is, so we actually have to give it to something, right? So we're going to say self dot underscore. We're going to privatize it. And the data member we're going to give it to is going to be X underscore coordinate, right? Remember, it's still Python, so we type everything in snake case, right? So X underscore coordinate is equal to whatever X is being given to us. Then we're going to create our Y coordinate. Can you guys hear the vacuum in the background before I continue? No? Okay, perfect. Sorry, my wife decides to clean right now of all times. I swear. We're going to give our Y coordinate the parameter of Y. And then notice that it takes 2 parameters and uses to initialize the coordinates, but it also initializes the odometer to 0, right? We were told it takes 2 parameters, but then now they're mentioning odometer, but they didn't say that we're supposed to pass in an odometer. But it's supposed to have an odometer. And we talked about customization within our classes. And this is non-customizable, like customizable, right? Every cab is going to start with an odometer. It does not matter, right? So we can predetermine that within our init method. So we'll do self._odometer. And we're going to assign it the value of 0. This is predetermined. You cannot change this. We did not give the class the option to pass that in as a parameter to override it. No, it's preset within our init method. It will start with 0, right? So it takes 2 arguments, but it has 3 data members. Make sense? So the class, what am I saying? The class does not need any set methods. But it should have methods called move X and move Y, right? These methods should take a parameter that tells how far the taxicab has shifted left, right, or up and down, right? But it should also have methods to be able to grab the coordinates as well as the odometer. So we'll use the get ones first. All right, so we're going to define get X coordinate. It's in a class, so it needs self. And all it needs to do is return to us self._x_coordinate, right? This is essentially our getter method. It's going to allow us to grab whatever our X coordinate is, our Y coordinate is, in our odometer without directly accessing the data member, like kind of how we saw with the dot, where we did dot.breed, right? Because these are privatized data members, we need to have a method to access these data members if needed to, right? But not the ability to manipulate them yet, right? So we got the one for the X coordinate. Now we're going to do one for the Y coordinate. Return self._y coordinate, right? And then same thing for the odometer. Get odometer and return self._odometer, right? These three methods should allow us to receive the current reading of where our cab is currently located at, as well as how many spots it's moved, right? How many paces or whatever. Now that we have the way to access the data members, now we need to actually give our functionality to our cab. This cab should be able to move, right? It needs to be able to move people from point A to point B. So we're going to create our move methods. So we're going to define move X. And the move methods should be able to take in some kind of parameter. This is going to be however far it has moved. All right, so we'll call it new X. And then the actual functionality of the method will be to update whatever our X coordinate is. All right, so we'll say self dot underscore X coordinate plus equals whatever new X is. All right, this will change the location of where the X coordinate is of our cab. But because it has moved, that means our odometer reading has changed. So we also need to update our odometer. All right, so self dot underscore odometer is going to plus equals what new X is. But notice, right, in the example, we have negative numbers, right? So there is a chance that our move X or move Y can move back. Well, if we try to add that to our odometer, it's going to subtract stuff, right, from the current reading. So to remove that ability, we're going to put ABS around our new coordinate. What that's going to do is going to set our new X to absolute. That means whether it's a negative or positive, it'll always be positive whenever it gets added, right? ABS stands for absolute, so the absolute value of whatever new X is. So even if we move -4 spaces, we still have to add 4 paces to our odometer because it's moved. Whether it was back or forward, it has moved. So we got the X. Now we're going to go into Y. So define move Y. Once again, it needs self, and it should take in a new Y coordinate. We're going to use that new Y coordinate to update what our current Y coordinate is by doing plus equals new Y. And then once again, update our odometer with the new reading. I'm going to wrap it around the ABS to ensure there's no weird funkiness, whether it's a negative or a positive number. And that should complete the class for our taxi cab. Finally, we're able to actually instantiate a cab and make it, right? We created the recipe, the blueprint for what our cab should be. And now we can actually create a taxi cab. So we're going to say cab is equal to taxi cab. And right off the bat, it already knows what taxi cab is. And it even tells us what it needs. It needs an X and a Y, and it can be anything. Right? I'm pretty sure we're able to ensure that this is an integer, right? And yeah, it says in any, right? But let's just keep it simple for now. Notice it's supposed to take in an X or a Y. So what's going to be our X coordinate? We're going to use the example that's given to us in the reading to ensure we have the correct answer, right? So we saw that this taxi cab started at X coordinate 5 and at Y coordinate 8. Right? Let's go ahead and print out cab. And we have that weird fucking, I'm sorry, I didn't mean to cuss. That weird functionality, right? That weird response of what our taxi cab object is with its location within our memory. So we know it exists. Obviously, we haven't added a dunder method to change the response of it. But we already know that if we're receiving this back, there is a taxi cab object that we have created. All right, so it's working. Now we're gonna go ahead and move our cab. So we're gonna say, actually, let's check where is it located at. So we can do print cab dot get X coordinate, and because this is a method, we have to use it like a method, right? We have to use open and close parentheses. It's a function, right? If you guys recall, it's a function. Notice that we defined it to not take any parameters, so we don't have to pass anything within here. Self, it just needed there for it to be created, but we don't need to pass anything in here. It doesn't take any additional parameters. And then we're gonna do cab dot get y coordinate as well, open and close parentheses. So it runs both these methods and it's gonna print out whatever they return. We can print that out and we see 5 and -8. So it's tracking what the data members are. We set it correctly and our method is working. Now we're gonna go ahead and move. So we'll do cab dot move underscore x. And this method, it takes a parameter here. It takes a new x. So we're gonna move it 3 paces, just like the example shows. We'll do cab dot move underscore y. We'll move it -4 paces, just like the example, and then we'll move the x again to -1, right? They should not print anything because we didn't have anything in the method where it's going to return anything. All we know that it's updating stuff, right? But notice that move x and move y don't have return, right? It's not supposed to return anything to it. If we were to print this out, it's not going to print anything. It might even say like undefined or none. So if we put print around cab dot move x, it's going to say none, right? Why? Because there's nothing being returned. It's doing something, but we can't see it because we're not returning anything. But if we do the get x coordinate again and get the y coordinate, we should be able to see what that is. All right, so we'll go print that out because we know that these are a getter methods, so they're returning something. Get y coordinate. And we see here that the first time we printed out before moving it, it was 5 and -8, right? Exactly what we added it. We then moved it for what the example was on the README. And we noticed that it's at 7 and -12, exactly where the README says that it should be at. So it's working. Now let's actually print out the odometer. We'll print out here before we move it so we can see the current reading. So we'll do print.cab get odometer. And then we'll print it out here after we move it. Print it out. So we see the original location of it at 5 and -8. We see the odometer, which was at 0. Then we went through the process of moving it and we printed out the coordinates again as well as the odometer. And we see how that changed. The position changed as well as the odometer, right? Because it moved 8 units. 3, then it moved 4 times to the -y, then moves again to the -1 on the x, and for a total of 8 paces. So that's how that works. Does anybody have any questions?
I just thought about it. So could you set the x coordinate and the y coordinate to a input variable and just play around with the the cab?
I'm sorry, come again? So like what?
So if you create a variable and use that instead of the number that's inside of move x or move y when you're calling it, could
Like if we
you?
did new x position is equal to 3 and then pass it in here.
Yes, I've set 3 to an input, integer input, and then
Mhm.
have the user play around with it.
Yep. You definitely can. It's gonna take whatever is in here, right? So we can do input. How far do you want to move the x coordinate, right? We'll go ahead and do it. It runs line 26 to 27, which was printing out the coordinate and the position. But then it gets to line 28 and it stops there because it's waiting for input. We'll say 3. Oh, okay. So it came back as a string, right? Remember we had to wrap it around the integer. Run it again. We'll say 3. I added a backtick by accident. There we go. Sorry. But yeah, so it'll work, right? We can receive input from the user. It gets added to the variable called new x coordinate. We pass that within the move x method, and it does take it as input.
Thank you.
No problem. Any other questions? Okay. All right. I mean, if you guys have questions, do ask, right? Because it's going to get more and more as we move further. All right. So that takes care of taxicab.py. Next one is going to be the
I'm
std
sorry.
dev.
I do have a
Yes.
question. How did that new X position, how
Come again?
was that able to work? How was that new X position able to work?
So
To
if
me,
you remember the input method, it asks you or it prompts the user for a response, right? And that's what we did. It reads your code from top to bottom, right? It prints out the x coordinate, the y coordinate, and the odometer, and then it got to line 28, where we created a new variable called new x position, and then we assigned it whatever our input is. If you recall the guessing game, right, or the coin assignment that we did where we received input from the user, and then that input is what we use to create our game. Same concept here. We did input, added our message. How far do you want to move the x coordinate? We added 3. We wrapped it around the integer to ensure that it's an integer once we get it gets added to our x coordinate, and then we pass that new coordinate within our move x variable. Earlier, as you saw here, we just added the number directly, -4, -1. This used to be 3, but instead of adding the number directly, we just added the variable, right? Whenever it reads line 29, it's gonna say, hey, what is new x position? What's assigned to this? Oh, well, the number 3, 'cause that's what was given to it whenever we asked for input. All right, so 3.
I got it. I was missing line 29. I didn't see line 29 with the new X position in parentheses there.
Okay, yeah. Awesome. Anybody else, guys? All right. Let's move forward. I hate this assignment. I'm not allowed to because I had to look up stdef. But go ahead and open up what stdef is in your folder. There's gonna be some research having to be done with this, right? So you're gonna write a class called a person that has 2 private data members, right? I'm giving you guys a disclaimer. This is slightly a little bit more difficult than what you guys just did, right? So this is gonna be a person class. It has 2 private data members, so it's gonna have to have the underscore method, right? The person's name and the age. It should have an init method that takes 2 values and uses them to initialize the data members, right? And it should have a get age method. So it should take in 2 parameters, and it was going to initialize 2 data members. Unlike taxicab, where it took in 2 parameters, but it had 3 data members. The third one was the odometer, and that was preset as default. This doesn't have that. So it should have taken 2 parameters instead of 2 data members. Cool. It should have a get age method, right? So we should have a getter method that's going to allow you to grab the self dot underscore age and then return it to whoever calls that method. And then you're going to write a separate function, not part of the person class, called stddev, right? Notice it is not a part of the class. So that means, like on the taxicab.py, right? Everything within here is the class. You're going to create a new function outside the class. So make sure you unindent and you create that new function, which in that situation is called stddev, right? So it's not supposed to be part of the class. You're going to write a separate function, not part of the person class, called stddev that takes as a parameter a list of person objects, right? A list of person objects. So you declare what your class should be. And then after the class, you have to create some objects. So make like person 1, person 2, person 3. Call the person class, create that object, right? Instantiate it. And then you're going to create a list where all these people are going to be at, all these new objects. And that list should be passed in within this function as a parameter, right? It takes in a parameter of a list of person objects and returns the standard deviation of all their ages, right? What is the standard deviation? We have a nice little link here. It's going to take a little bit of research, right? The population standard deviation that uses a denominator of n. I would be lying to you if I knew right off the top of my head what the heck this was. But click the link and you have a nice little page where you can read about it, right? The population standard deviation looks at the square root of the variance of the set of numbers, and it shows you how to do it, right? So to do it, you essentially have to grab all the ages. You're going to calculate the mean of all the ages, right? Pretty much the average of the numbers. So it should be adding them all up and then dividing them by the amount of ages that we have, right? Simple math. Maybe I got that wrong. Math was not my strongest suit, right? And then for each number, subtract the mean, right? So you're gonna go through each number, subtract what the mean was, and then you're supposed to square the result. Then calculate the mean of those squared differences. This is the variance. Take the square root of that to obtain the population standard deviation. So it's gonna take a little bit of math, but use these instructions to actually do the functionality within your std_def function. Okay? It's a little bit more complex than the one, as you guys already saw. Here we see an example. We have 3 different people, P1, P2, P3. Notice that each one of these objects, you have to call the class, and then they pass in the parameters that's supposed to take place of those data members. Hyungmin, I don't know if I'm pronouncing that correctly, 73, Mercedes, 24, Beatrice, 48. After they created these objects, they added them to a list. We see person list is equal to P1, P2, P3. And then they create a variable called answer. Within this variable, they call the std_def function and they pass in the list. And it should return to you the standard deviation. Awesome. Because this is going to take you a bit longer, we're going to get a little bit more time. Time is 7:07. You guys have until 7:30 to complete it. From 7:30, we'll go into a break and then we'll do this at 7:40. Sound good? So you have to use the init method every time you make a new class. Yes, Gary. Try not using it. Tell me how that goes.
I'm having trouble figuring out how to get just the ages from the list in
Go ahead.
this view function.
Share your screen, brother.
I was gonna ask the same thing. I'm just getting the person object gibberish.
Okay, I see you, Brandon. Awesome. Thank you for showing up. Appreciate your help. But yeah, so let's get to you, James. I'm recording now because it's always a good learning. If you're having issues, I'm sure someone that's following along with the videos is having issues too. So you're trying to loop through the persons list, right? So you start off, well, for person in person list. And then where do you think your issue is at right now?
I'm not sure. I think it's this. I'm not sure if I'm supposed to use the method here, but it's grayed out, which means it's obviously not getting it right. And I tried, I don't know if this was supposed to be self instead, but that didn't seem to look promising either.
No, you're doing the right thing. Try it out. Why don't you console log it? Instead of adding it, just console log it.
Just this right here?
Yeah. When in doubt, console log it.
Uh-huh.
See what is being printed out. All right, and then we have. Go ahead and.
Looks like it should.
Yeah, you should be able to just run it and you'll see it. Yeah, 23, 73, 24. It's working.
Oh.
Mm-hmm.
Okay then. Yes.
IntelliSense isn't going to pick up on that because it's a custom property. So it's probably not going to pick up on that. You'll have to download some other IntelliSense extension for VS Code in order to get that to show.
Okay, I think I understand. And that's just because I made it myself up here that it will not really register.
In most cases, yeah.
Yeah,
Okay.
I mean, and you gotta think about it this way, right? It doesn't know what dot get age. Like, it doesn't know that's a pre-built function or method that you created. As of right now, all it knows is that there's items in a list that you're supposed to be passing, and these items are supposed to be having a method. Well, it won't really know until you actually add a list of objects in there. And then, like, right now, by the definition, it doesn't know what the heck get age is because it doesn't really exist yet until you instantiate it. So right now, it looks like it's not gonna work, but if you were to run this function with an actual list of objects that actually do have these methods, it'll understand.
Okay, great. Awesome. Thank you. I will try to figure out the rest from here.
I
No problem.
believe if you were to instantiate the person inside of that function, so like if you were to, I think you said like S1 is equal to person, and then you passed your arguments. If you instantiated person inside of that function that we were just looking at, I'm pretty sure get age would show up as a property of that class.
Okay, interesting.
Maybe, but that's because you're specifically telling the program inside of that function scope, hey, we're working with a class right now.
Okay,
I
got
think
it.
it's a good way to put it. Thank you, Brandon.
You're muted.
Oh, I hate myself. I do it every single time. So I had this thing where I can mute my headset through a button on my headset, right? And I have to do it because sometimes I am like very. You ever feel like you might be talking on your mic by accident, nothing's muted. I don't know why I'm just scared that happens. So I have to mute it both because it drives me insane because I feel like somehow everyone can hear what I'm doing. So I apologize. All right, let's go ahead and continue with the stddev.py. I do have my notes up here because I'm not good with math, but we can go ahead and do it together. Let me split my screen and then share. All right, can you guys see my VS Code?
Yes.
Awesome. Okay. All right, so we have to create a class called person that has two private data members. This class is actually fairly simple and pretty small. So we can go ahead and create that class person. We have to initialize it with our init method with self, and as the instructions say, it's taking two data members, one being the name and the other being the age. And then we have to actually assign these parameters into the data member, right? So we're going to use self._name is equal to name, and self._age is equal to age. Right? Pretty straightforward up to this point. You should have the init method that takes two values and uses them to initialize the data members, right? And then it should have a get age method. So after that, we're gonna go ahead and come down here, create the get age method with self and nothing else, right? It shouldn't take any arguments or anything like that. It should just return to us whatever self._age is. That way, once again, they don't have access directly to our data members. They have to use a method to get it. Right, up to this point, everything else was simple. What I will do, different, is I'm going to create the dunder method so we can actually visualize what people are. So I'm going to use a dunder string method. And then I'm going to return a format string. It's going to say person. And then within here, we can have it formatted like this, self_name. And then age, self_age, right? So we get something nice once we print it out to visualize our person, right? And this is where it comes in handy, especially when you have people like this. Like if you were to create a class for like all the students in a district or in a school, right? Being able to see the students, student IDs, and yada yada, the grade levels. And you have like different objects like that. Stuff like this can help you visualize what all these objects are without having to go directly on each one and trying to do get name, get student ID. Right. So next, we're going to create our persons. We can just go ahead and copy this to save some time typing. But essentially, we create 3 different objects, P1, P2, P3. Each one is being instantiated with the person class, and then we pass in their name and the age, just like the init method is asking from us, right? And then let's go ahead and print. We're going to do for person and person list. I want to do print person, and we can see how the dunder method is going to work on that. We can get a nice representation of that. We see here person, and it's formatted the exact same way we formatted on line 8, where it gives the name and the age, right? Once again, going back to the analogy of having, a list of different objects. Like if you were trying to grab all the students within a certain district, and they're all built by as objects, it would suck to have to go through every single one of them and try to get age, right? Well, if you could just print out every single one, it just does it pre-formatted like this. If there's important information that you need to get. Cool. Now, the next step was to create a separate function, one not part of the person class. Let's go ahead and remove this part right here. And this function is supposed to do the std_def that they're requesting. So it's going to be def for define, and it's supposed to be called std_def, right? And this function is supposed to take in a list of person objects. Well, we already did that here, right? We created the actual object itself. They've been instantiated, and then we created a list, right? Each one of these holds an object, right? We loop through them, we printed them out, and it printed out what the objects are. So within here, we'll add the parameter, which is going to be person, person list of objects, right? Whatever. All right. Now, this function is supposed to take as a parameter a list of person objects and returns the standard deviation of all their names. All right. I'm not going to go through these, the website. We already kind of opened it up and talked about it. But essentially, the first thing that we need to do is grab the age of every single person that we have. And we saw that James kind of did it a little bit earlier. So we're going to do for person and list of objects. We'll say list of person objects, so no one gets confused. List of person objects, and then we want to grab the age and grab the total of it, right? Because we essentially have to find the mean of this. So we're going to have to create a variable for it. So at the very top, we'll do total is equal to 0. And as we loop through, we're going to do total plus equals person dot get age. We have a method for it, so use it, right? So every time as we loop through this list, we'll grab each object. We use the method that's built into that object to grab that age and then add it to our total. So as we get the total is changing, and then we have to grab the mean of all the ages. So we'll do mean of ages is equal to, and as you guys may know, to grab the mean or the average, we have to divide, right, the total by the amount that there is, right? So in this situation, essentially, it's the length of whatever our list of objects is, right? So we have 3 people, so we have to divide the total of what they are by 3 because it's 3 people, right? And that will return to us the mean of the ages. Then after that, we have to get, I believe we have to go through every single person, grab their age, and then subtract the mean of the ages, and then multiply it by, or I believe to the second power. Am I correct? Is the math correct there?
I think it's by 0.5.
Did you already subtract the mean?
I have not subtracted the mean. I've gotten the mean of the ages. Let me just check here. All right, so for each number, subtract the mean and then square the result. Okay, there we go. All right, so we have to go back to the ages and subtract the mean, right? So once again, we're gonna do for person and list of person objects. Is there a cleaner way to probably do this all at once? Maybe, but we're taking it one step at a time. And actually, we'll do something like this, right? So to make it easier for people to understand, right? So hash, we'll do a hash right here, so we can do add a comment. And we're essentially trying to do grab total, grab the total of ages, right? After that, what did we do? We did found the mean slash average of the ages. And then afterwards, we want to do what? We want to subtract the mean from each age and square the result, right? And if you guys are not used to comments, if you guys get very confused and you guys are coding along, stuff like this can really help you out to make sure you're staying on track, especially once your code gets very long. You can kind of lose track of what you are doing, what the method should be doing, what function is doing what, where stuff is going. So this is a nice way to just kind of keep you on track. So we're looping through our list of person objects, and after each one, we're going to subtract the mean of the ages from the age of the person, right? And then we have to get, essentially it's going to give us a new number. So we'll create something like this, like new result is equal to, and then we have to do person dot age or dot get age, right? Because that's the method that we created. Minus, what was the mean? Mean of ages, right? And then we have to grab that result and square the result. So to square it, it's 2 asterisks and then 2, right? And this coming from the explanation of what STD dev is, right? The standard deviation. It should be step 2, right? For each number, subtract the mean and then square the result. So each number we have to do, we have to subtract the mean and square the result. And that's going to give us a new number, right? Well, this essentially changes all the ages. So we need to keep track of every single one that we change. And add to a list. All right, so essentially we need to create something like list of results. So every time we change the age, we need to keep track of that change, right? It's gonna be an empty list. Once you grab that new result, all we're gonna do is add it to our new list of results. List of results dot append new result, right? Not to get confused with JavaScript, which is push, where you add something to a list. For Python, we use append, appending it to the end of the list, right? So every time we format that age, we're gonna add it to our new list of results, which is pretty much just a list of formatted ages, right? Per whatever the instructions of stddev is. Now, finally, next step is to calculate the mean of those square differences, and that will be the variance, right? So once again, we have to loop through something else, which is going to be now the list of results, right? Because now these are the new squared results. We have to do for result in list of results. And we have to calculate this mean, so we'll probably have to make a new variable, and this will be total mean is equal to 0. And let me just add some notes here so I know what I'm doing. Calculating the mean of the squared results. And then this is a variance, right? So that's coming straight from the SSD website. So essentially, I have to go through the list of results and then add them to a new total mean. So it'll be total mean plus equals what result is. And then the variance will be total mean divided by the length of list of results, right? The amount of items that we just added up, right? So we got the variance. After that, we're supposed to take square root of that to obtain the population, right? Variance. So square root the variance to obtain the population standard deviation, right? So essentially we do STD is equal to variance, and then how do we square roots? You can square root by doing to the power of 0.5. Am I correct here? Okay. Right? And that should be our STD. We can now just return STD. Cool. So essentially, we should be able to create our answer. Answer is equal to, and then run our function stdef and pass in the person list we created. And let's print answer. Print answer. Did everyone receive this number?
Yes, sir.
Right on, boys and lady.
No, I had got a different number. I think my math, somewhere in my math is wrong. I was following the instructions on the website link.
Mhm.
So I wound up getting the number 200, but so yeah.
Okay. To be fair, the instructions might be a little confusing. They are a little confusing to me. So if you got the wrong number due to just not understanding the explanation of SCDEF, don't worry too much about it. The main point here is to understand how we can create a class, make objects, and then use those same objects in different functions, right? And how we can loop through a list of objects, use those methods on each one. Right, that itself is the main exercise that we're trying to work on here on the STD-Def assignment.
What it was, at the end, I used 1 divided by 2. Once I changed it to the 0.5, then I got the same thing you got. So that's what it was.
Right on. There you go. Awesome. Does anybody have any questions? Not necessarily about the STD-Dev and the math behind it. Any questions in regards to the either the class / objects, how the function is working, how the methods are being called? Any questions in regards to overall just class and objects in general?
I have a question, Roger. So we could use the get age method outside of the class. You could use it in any function once you create it, basically.
Yeah, right. So the class itself, the class person, all it is a blueprint, right? It is a blueprint to create an object. When you go and you create an object, it will take everything that is defined within the class and it now has that functionality, right? That's what the blueprint is. When we got to right here, when we did P1 and we did person and we added the parameters, at this moment, a person object was created. This person object, it now has all this information within it. It can now use the get age method, right? So yes, every single person object that has been instantiated can use it. Think about it as yourself, right? When you were created, you have the ability or the method, and we're talking in regards of the concept of class and objects. The methods you had were, blinking, breathing, right? Default methods that you were born with, or the fact that your heartbeat your heart beats, right? And so on and so forth. All these methods you naturally had on you when you were created, when you were instantiated, right? That's what essentially is happening here at P1, P2, P3 on lines 43 and 45. These persons are being created, right? These objects are created. And they take all the methods that were defined within their creation. So yes, each one can use that get age method.
So
Right?
if somebody else wanted to use this get age, they would have to like import your person class.
Yeah, if
And
someone
then
wanted,
anybody can use.
yeah, if someone wanted to use this class, they can import my class and they can utilize this.
Okay. Okay, that's
Yep.
cool.
And we'll talk more about imports. You guys are gonna have to do that for one of the assignments, where you can create different methods in other files and import them and you can use them. Right? That way you don't have to keep repeating yourself, but you can create stuff and then instantiate it, right? Obviously you can't go to a different file and then just type in person and then try to instantiate the class if you don't have access to the class, right? If you don't have access to the instructions of how to create that person, then it won't work. So you have to import the class so you can use it. Anybody else, guys? All right, right on. Let's go ahead and move forward. So that took care of FTD def. Right, next, passing objects as arguments. The object can be passed as arguments to any method because everything in Python is an object, right? So this is an abstract concept, so it's okay if it's not clicking just yet. We see here on the right side, we have, once again, our pet class. It has the same init method. Notice on line 8, we have a get name method, so we have a getter, right? A getter method that allows us to receive what the name is, since name is a private data member. We then have a class home, right? Right afterwards, they define the class called home. The home class has an init method that takes in an owner, right? Then they assign the data members on line 16 and 17. We create self._owner as well as self._pets. And actually, let's kind of code along to make sure we kind of see this in real time instead of just talking through it. So here is my class example. Let's go ahead and remove this. We're going to define our pet class. And as mentioned before, it has an init method. It takes in self like every other class, and it takes in name as a parameter, then assigns it to the name data member. Right? It also has a getter, which is get name self, and then return self._name. Right? This allows us to access the name. What we just introduced was a new class called home. Right? The init method takes in a specific parameter, which is owner, right? And then we assign the data members. Owner is equal to owner. And notice that we have a data member called pets, and it is an empty string. It's not being passed in as a parameter, right? It's a default that comes with a home because naturally homes could have pets, but not every home has a pet. So by default, we're just going to go ahead and start this home object with an empty list data member, right? It gives them the option to add pets later on in the future, right? Later on, you decide, you know what, I'm gonna get a cat, then you can get a cat. So we instantiate this object with an empty self.pets data member, which is essentially just an empty list. And then we're gonna go create some different methods. One's gonna be adopt a pet, right? This is going to take pet object, right? Notice it's taking an object as an argument, right? So this class has a method that's taking an object, just like we've been giving it variables, right? Whether it was a string, we passed in a list of objects, we can pass an object directly. And then this method itself is going to add within our pets data member, we're going to append that pet object, right? It has another method called show pets, right? Essentially, it's pretty much just a getter method that's going to allow us to access the list of pets. So they should be return self dot underscore pets, right? So whenever we use this method on the home, it should return to us the list of pets that we have within this home object, right? Now we can actually start creating these classes, right? So we're gonna create a pet. It's gonna be pet 1. We're gonna instantiate this pet. We'll call this Oliver. That's my dog. Right, notice that we're only passing in the name because that's the only thing that this pet class is taking. It's not taking no breed or age. The only thing that we need to instantiate this pet is just Oliver. Next, we're gonna have to create a home. This is gonna be my home, right? So my home is equal to the class home. And who is the owner? Well, it is me, right? This home takes in an owner. It's just a string. It sets it to the owner data member. And now we can print out what these show. Actually, let's go ahead and do a dunder method for both of these. We'll define dunder string self and then return self dot underscore name. Same thing with the home. We will define the dunder method for string and it returns a formatted string home owner is equal to whatever self dot underscore owner is. Right. So we go ahead and print pet 1 and my home to see what it is. And then let's run our file. We see here it prints out Oliver for pet 1 and then prints out whatever the class for home is, which is homeowner with Roger, right? Cool. So that's working. Now that we have both of these classes, I currently have my home, right? This is my home. I am the owner. I don't have any pets, right? I can do print my home dot show pets, and it's not going to show anything. What's happening here? Oh, my bad. They use opening close parentheses. There we go. You see here, it returns to us what our show pets method does, which returns the data member self dot underscore pets. As we know right now, it is an empty list. I don't have any pets in my home, right? Now we can go ahead and adopt a pet, right? Oliver finally gets to leave the shelter and come to my house. So we're gonna do my home dot adopt.
Roger,
Yes.
can I ask you to slow down just a little bit? I'm trying to follow along, and when I did the print pet 1 and my home, I got that the object that shows where it is instead of the actual words that we want.
I might have gone a little too fast. I added these dunder methods, right? I define the string for both of these classes, and all I did was just to return the name for the pet, and then for the home, I return homeowner and then the owner's name. Right? That just kind of allowed me to visualize what these objects are doing. And then we printed them out here on line 30. I printed out the object pet 1 and I printed out the object my home. That showed me Oliver for pet 1 and then it showed me the homeowner object, which is homeowner Roger. So it showed me that my objects have been created. They exist. Next, I did my home dot show pets, right? I called the home object and I used the show pets method that I created, which is supposed to return to me what pets I have within this home. And we set the default to be 0, right? Because pets don't naturally just come out of nowhere unless you move into the house with a pet. But by default, a new home doesn't have pets, right? So line 31, when I printed out the show pets method and it returned to me the data member of pets, it came back as an empty list. And we see that here on my terminal, right? It's an empty list. Next, I'm actually gonna go ahead and adopt this dog, right? I figured out him and I, we bond together. So I use the my home dot adopt pet. And the adopt pet method we see here, what it does, it appends a pet object. So this method is supposed to take in an entire object as a argument. So within the adopt pet method, I need to add an object. And the object I'm gonna add is pet1, right? We created that pet object up here at line 27. So this method takes in an object, and adopt pet appends that object within my list self dot underscore pets data member. Right? So now I can do print my home and use the show pets method that I created, just like we did here on line 31. And we can see the change of that. Okay. We see here at first I got an empty list, right? Because it didn't have pets at line 31. At line 32, I adopted a pet and added it. And then we do here print my home dot show pets, which is supposed to return to me the list. And it did return to me the list. Notice that there's only one item inside this list, and it's essentially my pet object, but it's coming back as the original hash, right? And reason for that is why isn't that showing me how it should be showing it to me? What if I do, for some reason it's showing it to me, it's still hash, it's not showing me how it should be, which is just Oliver. But I set it up here, return self dot underscore name. It's there, it's within my pets list, but for some reason, whenever I use the show pets method within the home object, it's returning to me the list of it, but it's still hashed in there. So we could probably do for pet in self dot underscore pets print self dot, no, we could do print pet. Let's see if that works. Method is not iterable. Oh, my bad. I used the wrong method. It should be pets. There you go. For pet and self dot underscore pets, print pets. And there we go. We see it being printed out. I'm getting a weird method here because I am calling show pets here, but I removed the return. But the point of the assignment is it's returning to me a list with the pets in there. Right. I don't know why it's still hashed when I do it this way, even though I changed the other method for the string. But it is in there, right? We adopted a pet and it's showing me the pet in there. What if we do for pet here, for pet in my home dot show pets print pet. There we go. Now it's working properly. If I just call the method show pets, it's gonna send me the entirety of my list with all my objects in there. But it's essentially what it's doing is printing out the overall top level of my list. So therefore, it's not printing every individual pet in there on its own. I had to loop through my show pets method, which is essentially returning to me a list of objects. And then after I got every single object, I had to print out that object individually so it could show it to me with the Dunder method working. But pretty much, I was able to pass in an object within this method of another class, and I was able to use that object within that class, right? I saved it into the data member, which is self._pets. Did I by any chance lose anybody? No. Yeah, so I'm pretty sure you guys can kind of already see why classes and objects can be a little heavy to wrap your around. And imagine jumping straight into the immersive program and seeing it for the first time. You only have like 2 weeks to catch up with Python and get tested on it. So it's doing you guys some good that you guys are here and going to the headache now before you guys get into the immersive program. The point of this was pretty much I created 2 different objects. One was my pet object and one was my home object, right? This home object had a method that allows it to take in another object as a parameter, right? And we see that here on line 21, a dot pet. It takes in a pet object and then appends it to a data member within that home. So you can pass in other objects as arguments into methods from other objects. Cool. All right. Moving forward. This is an abstract concept, so it's okay if it's not clicking just yet. All right. Do you know that? Creating objects of one class inside of another, right? Here is the next one. This might be a little confusing at first too, but we're gonna work together. All right, so we're gonna create a new class. This is gonna be called club. All right, it's gonna be a club class. We're going to initialize this class with self, and the only parameters to take will be the title. This could be the name of the club, right? We're gonna assign that title to a data member, which is self._title. We'll assign title in there. And then we're going to create a get method called get title, which should return to us the data member of title. Once again, allowing us to access a data member without directly calling the data member itself. Now, afterwards, we're going to create a separate class. This class is going to be called club association. We're going to initialize it. And the only thing the club association class is going to have in the data member will be recognized clubs. Notice it takes no argument when we instantiate this object. By default, it'll already start with an empty list of recognized clubs, right? This is the club association. When you first start the association, you don't naturally just start with a bunch of clubs, right? We have to kind of build the association, right? So by default, it should start with an empty list. Now, this club association is going to have a method called add new club. Right, it's going to be self, and it should take in title. Right? Why is it going to take title? Well, because the club association should be able to start up a club on its own. And if you recall, what does a club take? It takes title as a parameter. So within the club association class, we have the method called add new club. This method will be able to create individual objects of another class. Within here, we're going to create new club object is equal to club, and then we're going to pass in the title that's being passed into this argument. Notice, right, the club association is creating a club class, right, a club object, right? So it's an object being able to create a different object from a different class. Right? This object, once again, we defined it up here, right? And then we're able to use it within a different class. Next, we're going to update our recognized clubs. Once it's created, we should be able to update that data member. So we're going to do self._ recognize clubs .append, and we're going to add that new object we created. We're going to create a new method called list available clubs. It's essentially just a get method, right? This should be able to print to us, or honestly, it should be able to return our recognized clubs. But we're gonna do print self._ recognize clubs. This is going to print to us the list of clubs that is recognized by the club association, right? Now, let's go ahead and create a club association, right? So my club association is equal to, we're going to call the class club association, right? Does not take any parameters. As we defined it, it should take nothing but start with an empty list of recognized clubs, right? This association is going to decide, you know what, I want to create the very first club. So I'm going to do add new club. This method will create that club within itself, right? So all it takes is a title. This club is going to be called chess, right? The chess club, right? We're going to create another club. So my club association should be able to create another one. This is going to be called, we're going to use the examples on the slide. The Baker Street Irregulars. I don't know why he chose that. Sorry. Excuse me. Let's create another club. They'll add new club. This will be called Food for Thought. Man, Guillermo was hungry when he created this. Right? So this club object was instantiated, and then we use the add new club to create club objects within itself, and then immediately add it to our self._ recognize clubs data member. Right? So let's go ahead and call the my club association and use the list available club method that we defined. CD lesson 08, Python classes example, right? And we see here, it prints it out. It is a list. Notice that there's still hashed, right? So it doesn't show us the club. You know, we don't have any dunder method defined for the club, but we get the main gist of it. We see that it's a list, right? Per the method that we define, list available clubs is supposed to print out self.recognize club, which is a data member of an empty list. But it's not empty no longer because we created new clubs and added something to it. Uses the add new club method. And it did do it effectively. It created that list. There is 3 different clubs within here, club objects. Right? So we just covered creating objects of one class inside of another. So classes or objects can call other objects within itself. Next, using objects of one class inside of another. So once a class object has been created, you can access its methods, right? It is going to build off upon what we just talked about. Going back to the code, we have the add new club. Now let's see if we're going to create a new method. It's going to be called define check title. Right? It's going to have self and nothing else. Within the check title method, we're going to do a for loop. We're going to do for club object in self._ recognize clubs, right? What we're doing here is we're looping through our data member, self._recognize clubs, and we're gonna grab all the new clubs that are in it, right? So for club and self._recognize clubs, if club object dot get title is equal to chess, let's move the extra. There we go. Then I want to say print, yes, that is a recognized club. Right? So notice that what we are doing within the club association method, we are looping through our list of different clubs, grabbing the object and using the methods that that object has, right? We define get title within the club class. We use that to grab its name. We compare it to see if it exists, and then we're printing out, yes, that is a recognized club. So we can do my club association dot check title. And let's go ahead and print it out in our console. And we see here, yes, that is a recognized club. Why? Because the club does exist there. We created it on line 29. It's within the recognized clubs list data member. So whenever we run check title, it's looping through that data member, grabbing the object, calling the method that belongs to that object, get title, and it's checking if it shares chess, right? And what does get title do? It returns to us the title of the club. So this will return to us chess. We compare it to the string chess. Hey, it exists in here. So yes, we can print out, yes, that is a recognized club. We can also do else. Just print out, no, it does not exist. So let's change this. We can make this a little bit more dynamic. We can actually pass in an argument here. We'll call it title or check title. We can replace the chess string and we can compare it to whatever comes back from the get title method. And then we can actually add some more functionalities. We can see within here, check title, does chess exist? Blah, 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 blah. It says, no, it does not exist. Why does it not exist? I'm sorry. Hello. Why is this not working? Check title. For club and audience self-recognized club, get title. Why isn't it not working? Let's figure out why it's not working. So it tells us, yes, that is a recognized club. But then it prints out, no, okay, my bad. It's looping through the entire thing. Right? That's why it tells us, because there's 3 different objects within here. It gets to the first one, which was chess, and it returns, yes, that is a recognized club. Right? Due to the way that we formatted this method. But it's still looping through the other ones. All right, so let's remove the else statement. And we see that it does no longer checks the ones that do not match to it. Right? But once it reaches the one that it does match, it'll print out, yes, that is a recognized club. Right? We can switch this to what's another club we could do? Photography. Right? We print it out and we notice that it does not show us anything. Right? Because it does not exist. But yeah, that's how that works. Using objects of one class inside of another. In summary, you can use objects of the same class or another class inside any method. A method can accept an object of any class as a parameter in the same way that it would accept an integer or a string or any other variable. By default, a method will always have a self parameter, and self will reference the object on which the method was called. You guys been seeing that every time we create a method, we have to use self. When a method takes an object as a parameter, you can call methods on it that are defined for that class. You saw that with a club. We use the check title method. And then we're gonna do one more assignment before we call it for the day. It's gonna be the line segment.py. So going back to our assignments, if you go to lesson 8, go to line segment, you'll see a formula here. You guys can use the formula, but essentially, what you guys need to do. Oh, lower is a big one. Okay, I'm gonna leave this one as homework, right? We'll do this as homework. That way you guys can try it out. We can start it here, and then once time is over, we'll cut off for the day. Excuse me. And I'll be here for any questions. Or would you guys prefer we just stop it now and I leave it open for Q&A and answering any questions you guys might have?
The
Let me
latter.
see.
I think the second option.
All right. So we'll stop it here. So I don't override you guys with questions. I'm sorry, overload you guys with work. Let me stop the recording.